Welcome to section 7.3 part 2. We're still on trig integrals. This is integrals involving secants and tangents. We had rules for sines and cosines last time. These are going to be similar, just a different set of rules. I'm not going to write these out. You can read them in your book. We have 3 rules. They're on page 500 if you're interested, and you should be. The first one is if the power of secant is even and positive, save a secant squared factor and convert the remaining to tangents. So let's see how that works. We're going to take our secant to the 6th of 3x. And if you're trying to integrate that, it would be nice if you could let u be the secant of 3x and then du, and there's where our problem. If we could have secant to the 6th 3x, and if du were present, we could just make this secant to the 7th over 7. But the derivative of secant from way back when is secant tangent. So there is no secant tangent anywhere to be found. So this strategy is not going to work, and therefore we need a new plan. So what the rule on page 500 says is save a secant squared and turn everything else into tangents. So let's take 2 of those secants and just save them. And then the rest, the other 4 secants, are the ones that are going to get transformed into tangents. And what we have are 2 secant squared 3x terms. Okay, so instead of expressing it to the 4th power, we'll just do it to the 2nd power and then square it. So this is always going to work out because our initial condition was we had an even positive amount of secants, in this case the 6th power. So if you take 2 out, you're still going to have an even number. Okay, so again with trig identities, we're going to change the secant squared of 3x to 1 plus the tangent squared of 3x. And now that is all squared. Okay? So please never do this. Never turn this into 1 plus tangent to the 4th. Okay? Squares do not distribute over parentheses. You have to write this thing twice and FOIL it. If you don't want to write it twice, you have to FOIL it in your head. But one way or the other, this 1 plus tangent is getting FOILed. So when you do FOIL something in your head, you square the first term, so you do have the 1, and it's plus 2 times the 2 terms multiplied together. So we would have 2 tangent squared 3x plus the last term squared, which would be tangent to the 4th 3x. Okay, I make a big deal out of that because I see it all the time. Please don't distribute a squared over parentheses. And if you're not convinced that's what it is, write this binomial out twice and square it out the long way. Okay, so now we're kind of in a similar place as we were with the sines and cosines. We're going to distribute this secant squared to all 3 portions of these parentheses. We're going to get secant squared 3x when we multiply it by 1. And then we're going to get plus 2 secant squared 3x tangent squared 3x plus tangent to the 4th, or secant squared 3x tangent to the 4th 3x. So all 3 of these parts are now we're now able to integrate because of the u-du relationship between tangent and secant squared. Okay, the derivative of tangent is secant squared, which comes right out of the front of your book. So like with the sines and cosines, I can do tangent to the any power as long as I have a secant squared there to go with it. So I've got a squared and a 4th that it doesn't matter what those powers are because du is present, so I can deal with those individually. Okay, so first we integrate secant squared. And the integral of secant squared is tangent, because the derivative of tangent is secant squared. So in this case, this one sets up perfectly, other than the fact that I need an extra 3. Okay, in this case, my u is 3x, my du is 3 dx, and I've lost my dx's along the way, but I need a 3 dx to be there, so I'm going to need a 1/3 on the outside. And so my final result is going to be 1/3 tangent of 3x. Okay, and on this second portion, because I have tangent squared, and I have the secant squared to go along with it, then my u, my u is going to be the tangent of 3x. If that's the case, the derivative of u would be 3 times secant squared of 3x, okay, because the derivative of tangent is secant squared, and then the chain rule produces an extra 3. So if I'm going to treat this like a u squared du problem, I need there to be a 3 secant squared 3x. And I almost have a 3 secant squared 3x. I have a 2/3, so I'm off, I have a 2 secant squared 3x. So I need that 2 to be a 3. If you need to change a 2 into a 3 through multiplication, then multiply that 2 by 3/2, and then 2/3 on the outside to make up for it. Okay, so back to my answer. 2/3 is part of the answer, and tangent to the second power now becomes tangent to the third power of 3x over 3, because the integral of u squared is u cubed over 3. So there's my u cubed over 3. The trickiest part here is getting the constant right. Okay, so that all together is going to become a 2/9 tangent cubed, and I'll get that when I clean it all up. Okay, similar thing over here. U is tan 3x, so du is 3 secant squared 3x. I need there to be a 3, and right now I don't have anything, so I'm going to throw a 3 in, and I'm going to throw a 1/3 on the outside to make up for it. And I know there's not an integration symbol with each one of these, but there could be, and this 1/3 would be on the outside of that integration symbol. So altogether, I have a 1/3. All of this 3 secant squared 3x, that's all du, and so that's all going to go away. Same with this secant squared. All of that serves as du, and then it goes away. Okay, so we had 1/3 because of our constants, and tangent was raised to the 4th, so since we're integrating u to the 4th, it's going to become u to the 5th over 5 plus c. And then just putting all that together and cleaning it up a little bit, I have 1/3 tan 3x plus 2/9 tan cubed 3x plus 1/15 tangent to the 5th 3x plus c. And all of that is your answer. Okay, and there are 2 other cases. What happens if tangent is odd and positive, and what happens if there are no secants. And they're just different cases that I don't have time to do one of each, but that's the main idea. It's similar to sine and cosine, and the other cases you can just refer to as we get to them. All right, so that's how you deal with an even and positive secant, and then you'll just deal with the other ones as we get to them. All right, so that's section 7.3, part 2, Young out.